now we're ready to automate the data input and the creation or the dynamic creation of nodes while the program is running. So in other words, your array or your data structure or your list, in this case, specifically a list, will increase every time you add a new client. It means you will get a new node that will be created at runtime. To be able to do that, let me show you some very key strategic lines of code that you're going to need. You're going to need a pointer for the new client you will create right here, and assign it to null, which means it's not pointing to anything. But once you're ready, that means now you could dynamically reserve memory space for that new node of type client. Now, notice one other thing I've done here. So instead of having struct written everywhere, just like the previous examples, I used a type def syntax and created a new data type called clients instead of client, okay? Which I can now use as a regular data type, okay, without the use of word struct. So notice now all of my pointers here are of type clients. You still need a head, and I still need a list pointer that I will use to navigate through the list. All right, so let's get back to our point. I needed this one, a temporary pointer, basically, that I would reuse every time I create a new pointer. Okay, so for that, you need to allocate memory space. So this is the key syntax behind this strategy, malloc. Now, malloc is a function, and somebody must have defined this function. Indeed, not me, not you. Somebody created it, and it's in this library, stdlib. So make sure you include this library, right? Just like we include stdio.h, so we can do printf and scanf, right? So same thing. There are some functions that are pre-canned for us that we could use. So stdlib will have the function definition for malloc. Now, how does this malloc work? Well, you're basically saying, okay, here's my pointer. I need you now to give me a space in memory, right, based on this pointer. And I want you to reserve that many bytes for this new object or this new node. And how do you know how many bytes? You don't have to count how many bytes. You just tell it, what is your data type? This is why I created type def. So this is my new data type, right? So if it takes, I don't know, 15 bytes or 16 bytes, I'm not going to sit there and count it. I know automatically this will be done for me right here. Okay? So size of clients. Great. So now let's look at the strategy of the program. Next, I created two variables, choice equal 1, counter equals 0. Now, counter, typically, it's an accumulator that allows me to count how many records I might have entered. So I always like to have that strategically in my code, even if I use it or don't, or partially use it, okay? So next is this choice variable. It's basically a sentinel for my loop if I want to keep entering new nodes. So sure enough, notice I primed it. I made it equal to 1. And what happened now is I asked, is choice not equal to 0? And well, guess what? The first time around, choice is 1, so you're going to get inside. Now you're given the opportunity to enter 0 or some other number. So as long as you enter any other number than 0, you're going to be staying in this loop, which means you are going to create a new node, right? And you will be asked to do something. But let's say you picked 1, other than 0, 1, then you will be doing things, right? So let's say you entered 1, right? Well, in that case, if choice is not 0, which means you didn't decide to leave, right? You're going to be doing all of these things, including the creation of a new node, right? So we'll see the details of that in a minute. So let's just make sure we understand how this while loop works right here. And that's what controls your data entry. Okay, so as long as you don't pick 0, you're going to stay in this loop, right? And you're going to enter new data or new node. All right, notice right away I incremented my counter because I am going to use that for my next if statement. Counter equal 1. Okay, so that means we want to create our first node. So that's my indication. This is the beginning. This is the start. Else, that could be anything. That could be 2, 3, 4, which means you're no longer at the tail of the list. Okay. If I'm at the tail of the list, which means this is my first time, and counter incremented from 0 to 1, in other words, at this stage, you might as well create new client next equal null. So ground it. Since it is the tail, make that pointer point to null. That particular pointer, which is a data member, right? Remember here? Right here? Which is a data member of the structure. And that's what differentiated from other nodes, because that one in particular points to null. Great. And go ahead and assign the head to this new node. Okay. Now, we don't put an % here because new client, guess what? It's a pointer. It already has an address. So no need to put an % like we did %CL1, for example. Okay. Good. Any other time, which means now the counter is either 2, 3, 4, 5, right? That means as this program ran, you added more nodes. Well, in that case, what you're going to do is the new client next, which means the moment you created a new object or a new node, go ahead and assign it to head, which means there had to have been a node where head was pointing at. Well, that's great because now you're trying to insert yourself at the top. So go ahead and look at that head, and your internal pointer is pointing to head as well. Now reassign head to this new node. And that's typically, this is where the magic happens. This is the insertion of a new node within that list. Okay? Once you're done, which means you structurally set up the list right here between these lines, now go ahead and populate your payload. So at this stage here, you're going to ask the user to enter the name and the balance. Notice here for the scanf, I did a combination of the string and the float all in the same line. So when this runs, it's going to ask, you're going to enter them in the same line and then hit enter. Okay, so you're going to enter the name and the balance. All right. Now, how about our loop? Well, for the output, or I'm sorry, yeah, so there is a loop for the output. But first, we want to make sure that, hey, what happens if the moment you started this program, you decided to put 0, which means you didn't want to enter any data, you just wanted to get out. Well, we have a contingency for that, okay? So that means list PTR will be null. Why? Because head will be null since you initialized head to null already. So if you pick 0 the first time around in your data entry, you never had a chance to change head to any other value, and it remains at null. And since your list PTR is equal to head, then it will be null, which means it will say no record were added. We're going to go through that scenario to demonstrate that. Else, or in our case, if this is true, right, it is not null, which means you either have one node or many nodes. So in other words, you have records. So the technique we used in the previous lesson is we went ahead and printed the tail or the head first. Okay, might as well go ahead and call it for what it is. And notice the technique that I'm using here for the loop. Again, same thing as the previous lesson. As long as the pointer, the internal pointer of the node I'm looking at is not pointing to null, okay, go ahead and increment or shift it to the next one, right? And then go ahead and print the content. This way, you're not going to skip the tail. If you put this below, then you'll have issues. So the order in which you do all of this is going to be important. Okay? All right, so let's go ahead and run this program. So compile and run. And let's go through the first scenario right now where I say 0. I don't want to enter anything. I just, ran this application by mistake. I want to gracefully exit. You type 0. And notice it says no records were added. Perfect. So that means you pick 0. None of this stuff in the if statement was evaluated. List PTR is actually null. No records were added. Excellent. So now let's go ahead and run it again. And this time pick 1 or 2, whatever number you want for this. As long as it's not 0, you're going to be asked to enter a record. So name and balance. Enter them all on the same line. So Henry and 100.23. Now let's say we enter just one record. And I'm going to hit 0. And you have records. Henry 100.23. Good. So now let's go ahead and run this again and enter a couple more records. And let's pick 1. Let's put Henry again and 100.21. Let's pick another one. And let's put Kelly at 34.23. Let's pick another one. Let's put 3 nodes in this list. And the balance is 90.3. Oops. Name and balance. Name first. Bob. And the balance is 93.21. Okay. Now I'm going to pick 0. And let's see if we get our data. Perfect. So we got Bob, we got Kelly, and we got Henry.